Chapter 1: The Evolution of Project Management Thinking by David Rollason. Project management has existed in one form or another for centuries. From the construction of the Egyptian pyramids to the building of modern transport networks, humans have always needed to plan, coordinate, and control complex work involving multiple people and limited resources. Yet formal project management, as a structured discipline, is relatively recent. It emerged in the mid-20th century as organizations began to recognize the need for systematic approaches to manage increasingly complex and time-sensitive projects. In its early years, project management relied heavily on intuition and experience. Managers planned activities informally and tracked progress through manual schedules and personal oversight. This worked in small teams or straightforward projects, but as industries expanded, new challenges appeared. Projects became larger, deadlines tighter, and dependencies more intricate. It was no longer enough to rely on personal judgment. Managers needed methods that could provide predictability and control in uncertain environments. The birth of modern project management. The formal discipline of project management began to take shape during the 1950s and 1960s. The post-war era brought rapid industrialization, technological advancement, and large-scale engineering and defense projects. These developments demanded more rigorous management techniques. Two of the earliest and most influential methods were the critical path method, CPM, and the program evaluation and review technique, PERT. CPM was developed by DuPont and Remington Rand in 1957 to optimize maintenance and construction schedules. It focused on identifying the sequence of dependent activities that determine the overall project duration. PERT was introduced around the same time by the U.S. Navy to manage the Polaris missile program. It used probabilistic time estimates to deal with uncertainty. Both methods provided structured, analytical ways to plan and monitor projects. They allowed managers to visualize complex work as a network of activities, calculate timelines, and predict the impact of delays. These methods marked a turning point. For the first time, project management became quantifiable and repeatable. However, while CPM and PERT improved planning, they also introduced a level of complexity that was difficult to sustain. Projects still suffered from late delivery, cost overruns, and inefficiency. Over time, it became clear that technical scheduling alone was not enough. The rise of methodologies and frameworks. During the 1970s and 1980s, organizations began to formalize project management further. Standards and methodologies such as PRINCE, later Prince 2, and the Project Management Body of Knowledge, PMBOK, were introduced. These frameworks provided structure, defined roles, and established best practices. They helped bring consistency across industries and professionalize the discipline. By the 1990s, project management had matured significantly. Software tools made scheduling easier, and project offices began to appear within organizations. Yet despite these advances, many projects continued to underperform. The reasons were familiar: unrealistic timelines, poor communication, scope creep, and overcommitted resources. Traditional approaches assumed that projects failed because of poor planning, but experience showed that even well-planned projects could struggle once execution began. One of the main weaknesses of conventional project management was its focus on individual task optimization rather than overall project flow. Managers tried to keep every resource busy, assuming this would lead to faster completion. In reality, this created inefficiency through multitasking, handover delays, and poor prioritization. Schedules looked precise on paper, but in practice, projects were unpredictable. The search for a better way. The recurring problems with conventional methods led researchers and practitioners to look for new approaches. Among them was Dr. Eliyahu Goldratt, an Israeli physicist turned management theorist. Goldratt developed the theory of constraints, TOC, in the 1980s, which focused on identifying and managing the system's constraint, the factor that limits overall performance. His work initially applied to manufacturing, helping companies improve throughput by concentrating improvement efforts on the weakest link in the production chain. Goldratt's key insight was that every system has a constraint, and improving performance anywhere else yields little benefit if the constraint remains unmanaged. This thinking extended naturally to project management. Projects, like production systems, are chains of dependent tasks limited by scarce resources. If one task or resource creates a bottleneck, it restricts the performance of the entire project. Goldratt recognized that traditional project management often overlooked this interdependency. Schedules were built around task durations and dependencies, but rarely considered resource contention or behavioral factors such as multitasking and task protection. Teams padded their estimates to protect themselves from blame, but this hidden safety time was often wasted. The result was frequent project overruns despite generous schedules. The emergence of critical chain project management. In 1997, Goldratt introduced critical chain project management, CCPM, as an evolution of the critical path method. CCPM applied the principles of the theory of constraints to project environments, focusing on system-wide flow rather than individual task efficiency. It addressed both the technical and behavioral shortcomings of traditional scheduling. Critical change shifted attention from completing tasks on time to completing projects as quickly and reliably as possible. It did this by identifying the longest chain of dependent tasks that considered both task and resource constraints, the critical chain. It then protected that chain using strategically placed buffers to absorb uncertainty without extending the overall project duration. Unlike the critical path, which assumes resources are always available, the critical chain recognizes that people and equipment are shared across tasks and projects. It eliminates multitasking, encourages focus, and uses buffer management as a control mechanism rather than arbitrary deadlines. The approach integrates planning, scheduling, and human behavior into a single coherent system. A shift from efficiency to flow. CCPM represents a shift in how projects are viewed. Traditional methods aim for local efficiency, keeping every resource busy, while CCPM aims for global effectiveness, delivering the entire project faster and with less stress. It challenges the idea that starting more tasks sooner leads to faster completion. Instead, it emphasizes finishing tasks in the right sequence with fewer interruptions. This shift also changes how project performance is measured. Instead of tracking individual task completion, CCPM tracks buffer consumption. Buffers act as indicators of project health, showing whether progress is ahead or behind plan. This enables proactive management, allowing leaders to intervene before delays become critical. Why critical chain matters today. Modern projects face more complexity, interdependence, and uncertainty than ever before. Teams are distributed, technologies evolve rapidly, and organizations manage multiple projects simultaneously. Traditional planning methods often struggle under these conditions because they assume stability. CCPM's focus on flow, resource constraints, and behavior makes it particularly suited to dynamic, fast-moving environments. By combining logical scheduling with practical psychology, CCPM creates a more realistic and resilient approach to project management. It reduces stress on teams, shortens delivery times, and increases reliability. Many organizations that adopted it report substantial improvements in on-time delivery and resource utilization. A continuing evolution. Critical chain does not replace other project management methods. Instead, it enhances them by focusing on what truly limits performance. It complements frameworks such as Prince2 or PMBOK by adding a mechanism for execution control and flow management. It is equally compatible with agile and lean thinking, which also emphasize speed, feedback, and value delivery. Project management continues to evolve, but the challenges remain consistent. How to deliver faster, with less waste, and with greater confidence. Critical chain. Project management offers a practical, science-based approach to meeting those challenges. It builds on decades of experience while addressing the root causes of project delay. The chapters that follow explain how CCPM works in detail, its principles, tools, and real-world applications. By understanding its origins and purpose, it becomes easier to appreciate why it remains one of the most effective approaches for managing projects in uncertain and resource-constrained environments.